Hello everyone. Let us begin our journey of exploring mathematics, of learning mathematics from its basic form, from learning to its basic principles, that is, first principles, to the level that we all will understand. Let us start with the chapter Real Numbers. So, what are numbers? Numbers are nothing but the arithmetic values which are expressed in the form of symbols or figures and are representing some quantities and are used generally for counting as well as calculation. That means numbers are just plain symbols or figures which have some value. Now, these numbers are divided into two broad categories. First is the real numbers, second is the complex numbers. Well, we will study the complex numbers in our further classes. Now, let us focus on real numbers. So, what are real numbers? Let us understand the basic and the most simple definition of real numbers. The real numbers are nothing but the numbers which can be represented on this number line. Well, you can see number line on your screen where we have the left side of 0 that are the negative numbers and the right side of 0 that are the positive numbers. All the numbers which can be represented on this number lines are called as the real numbers. Now, these real numbers are further classified into many types of numbers. But the major and two broad categories that are rational numbers and irrational numbers. First, let us focus on some basic categories of real numbers and then we will jump to rational numbers and irrational numbers. So, the numbers that you are seeing on the right side of the 0 and the numbers which are countable, that means the numbers which are positive as well as countable are called as the natural numbers. For example, numbers such as 1, 2, 3, 4 and so on. Now, when I include this 0 to the set of natural numbers, this will give me the whole numbers. That means whole numbers are the set of numbers with natural numbers plus 0 added into them. Now, when I take these negative numbers and the positive numbers as well as 0, that means whole numbers plus negative numbers, I would get integer. Now, let us move on to define rational numbers and irrational numbers. So, according to the definition, the rational numbers are the numbers which can be represented in the form of P by Q, where Q is not equal to 0 and P and Q are integers. For example, if I take the number 2, 2 can be represented as 4 by 2 or 2 by 1. That means 2 and 1 both are integers here and Q, that is 1, is not equal to 0. Similarly, I can write 4 is equal to 8 by 2 or 5 is equal to 10 by 2 or 6 is equal to 18 by 3 and so on and so forth. These all the numbers are the rational numbers. Well, the natural numbers, whole numbers and the integers all are the rational numbers. And the rational numbers have two types of decimal expansion. First is the terminating decimal expansion. That means the numbers which end after some decimal places called as terminating numbers. And second type of rational numbers are the numbers which are repeating as well as non-terminating. For example, numbers such as 0.6666667 and so on. Now, this number does not end. That means it does not terminate, but it has a recurring value that is of 6. This was all about rational numbers. Let us understand irrational numbers. Irrational numbers are the ones which cannot be represented in the form of P by Q, where Q is not equal to 0 and P and Q are integers. That means if I take an example of root 2, which has the value of 1.414 and so on. Now, this value will never end and we do not have specific number which will recur, that means which will repeat. We have also studied in our earlier classes that irrational numbers can be represented on the number line with the help of Pythagoras theorem. And the decimal expansion of these irrational numbers are of the type non-recurring and non-terminating. That means we have seen the example of root 2 where the numbers after the decimal point does not terminate after some places as well as they do not recur. There are many examples of irrational numbers. The common example is the value of pi. Pi, which is equal to circumference of circle upon diameter of circle, which is also irrational number. The value of pi is 3.141 pi 9, 2, 6, and so on. This will never end. In fact, the value of pi has been found out till the millionth decimal places, but it is still not terminating. Now, this was all about real numbers. So, in this chapter, first we'll discuss about the principle called as Euclid's division lemma, and further we'll go on to discuss Euclid's division algorithm, which is based on Euclid's division lemma, and further we'll study fundamental theorem of arithmetic. And after that, we shall study the irrational numbers, that means the proof of irrational numbers, and finally we'll discuss rational numbers and their decimal expansion.